Hey, I'm Jason. Welcome to our presentation. We researched Chapter 7, which is about proportion and similarity. Chapter 7 is made up of 5 different sections, which include proportion, similar polygons, similar triangles, parallel lines, and proportional parts, and lastly, parts of similar triangles. Are you ready? Let's get started now. Section 1 is about proportions and ratios. Now, what is a ratio? A ratio is something over something. We use ratios all the time, like in class or at the mall. Even political leaders use ratios for their plans for us. Now we move on to proportions. Now, remember, a ratio is something over something. So what if we have 2 ratios that are equal to each other? You get a proportion. Alright, we are now on section 2, which is similar polygons. Now, how do you tell if polygons are similar? Well, polygons are the same shape, but they're different sizes. So how do we know if the polygons are different? Let's see. Oh yeah, we have that thing called the scale factor. Now, the scale factor is a ratio between 2 sides of different polygons. We can also tell if polygons are similar by checking if their angles or sides are congruent. Alright, now we're on section 3, which is similar triangles. Now, a few years ago I went to Paris and I saw the Eiffel Tower. Eiffel Tower is made up of many different triangles of different sizes, which makes up the whole tower, and it makes it structurally sound in that manner. You can tell if triangles are similar. Brian, stop talking. You can tell if triangles are similar by checking their angles and sides to make sure they're the same angle measurement or the same side length. Alright, now here are some examples of ratios and proportions in our textbook. A over B is a ratio. Now, when you have 2 ratios put together, you get a proportion like this. Alright, you can tell if polygons are similar by checking the ratios. For example, in our textbook, we have 2 figures, the same shape but different sizes. This length here is 7 centimeters, and this one is 3.5 centimeters. So the ratio for these 2 segments is 1/2. Now, if we go to the bottom segment of the bigger one, the length is 8 centimeters, and for the smaller one, it is 4 centimeters. So again, the ratio between those 2 segments is 1/2. Same goes for this segment. This one is 4 centimeters, and this one is 2 centimeters. The ratio is 1/2, and same for this. This one is 6, this one is 3. The ratio is 1/2. So these 2 polygons are similar. Alright, so now we have an example of scale factor in the textbook. This is a miniature car. The length from the end of the wheel to the other end is about 1 inch. Now, imagine this car, life size, from here to here would be about 20 inches. So the scale factor between the car's wheels is 1 to 20. Alright, now we found triangles in the real world. Now, if you look at the roof on that building where that bird just landed, it makes a triangle. Now, if you look on my left, you'll see the other roof makes another triangle. So both roofs or both triangles are similar. Section 4 is about parallel lines and proportional parts. Now, this section has many pictures of this. Now, this is a right triangle. And this line, the mid-segment, is parallel to the base. Now, because these 2 are parallel, these 2 angles are corresponding, and these 2 angles are corresponding. As well as this segment is the same as this segment, and this segment is the same as this segment. Now, on the mid-segment, the end points are the midpoints of the line. So this is a midpoint of this whole line, and this is a midpoint of this whole line, and that's why they are each the same. Finally, we're at the last section, section 5, parts of similar triangles. Theorem 7.7 states that if two triangles are similar, then the perimeters are proportional to the measures of corresponding sides. This problem says to find the perimeter of triangle GHK. GHK only has the base, which is 5. Now, to find the perimeter, you have to set up a proportion. The proportion is going to be this base over this base, and it's going to equal the perimeter of this, which is x, and the perimeter of this, which we know is 84. Now, you have your proportion all set up. You multiply across and get 420. You multiply across and get 12x. 12x equals 420. You divide that by 12. X equals 35. The perimeter of triangle GHK equals 35.